Okay, today sympatholytic drugs. See, okay. See here under the sympatholytic drugs, what are the things to be focused? We need to focus towards the Gpat. One is drug classification. Okay, first one is drug classification. Next, what are the basic ring that can be identified in the drug structure, especially the phentolamine in the GATE 1998 they have asked. Next one is prazosin drug. Okay, prazosin in the GATE 2007 they have asked. Next, synthesis part also very important, that is for prazosin drug along with 𝘂𝙀𝙎𝙏. Next, ergot alkaloids and its derivatives and structure of quinazoline derivative. Okay, structure of quinazoline derivative. Here alpha blockers also we can call it antagonist, alpha antagonist. See, first one is non-selective drugs are there. Okay, first is non-selective drugs like reversible phentolamine and tolozoline. Irreversible drugs are 𝘂𝙀𝙎𝙏. Next comes to the selective drugs. When comes to the selective drugs, alpha 1 blockers like alpha-zosin, prazosin, terazosin, tamsulosin and doxazosin. Next, alpha 2 blockers, that is 𝘂𝙎𝙎𝑃 and 𝘂𝙎𝑃𝐿. Okay, 𝘂𝙎𝙎𝑃 and 𝘂𝙎𝙎. Next is miscellaneous drugs. Example is ergometrin and dihydroergometrin. See, alpha blockers, that is majorly used in the alpha blockers majorly used in the pheochroma treatment of pheochromocytoma. Example, pheochromocytoma nothing but prostate cancer it is. Next here prazosin drug is there. Okay, prazosin drug cannot be useful in the treatment of hypertension because it is having short duration of action. Hence it can be replaced with doxazosin and terazosin. So doxazosin and terazosin can be used because this drug having the longer duration of action. Okay, because this drug having the longer duration of action. Okay, next see, alpha 1 and alpha 2 receptors are there. Noradrenaline is a agonist to the alpha 1 and alpha 2 receptor. 𝘂𝙀𝙎𝙏 is a non-competitive antagonist. Next, alpha 1 and alpha 2 receptors are there. Noradrenaline is a agonist, phentolamine is a competitive antagonist. Competitive nothing but it will bound to the different site, sorry, it will bound to the same site of the receptor. Okay, noradrenaline it will bound to the same site, but 𝘂𝙀𝙎𝙏 that will bound to the another site. Next, phentolamine drug is there. See, phentolamine drug is there. In the phentolamine, phenyl group is there. Okay, phenyl group along with toluene moiety is there. So this is a toluene. Next, amine group is there. So here amine group is there. So this is about the phentolamine drug structure. Okay na. Next, IUPAC name. See, when it comes to the IUPAC name, first we need to identify the functional groups. What are the different functional groups are there? Hydroxy group, amine group. Okay, among hydroxy and amine group, which functional group we need to give more priority? Nothing but hydroxy group only. Okay, hence we need to start the numbering from hydroxy group containing one, like this. After that, toluene group numbering is like this. Next, imidazolin, like this. So how we can write the IUPAC name? We need to write the IUPAC name from the reverse. See, phenol, first we have given priority to the phenol containing drug. Phenol that can be attached to the amine. Phenol that can be attached to the amine. Amine that is containing two substitutions here. Okay, amine that is containing two substitution. What is that first substitution? 4-methyl phenyl. See, this is a 4-methyl phenyl is there. Next, what is there? 4,5 dihydro. See, fourth position, fifth position, it is containing hydrogen. Hence, we can write 4,5 dihydro, 4,5 dihydro, 1H imidazole. Okay, 1H imidazole is there. Next, 2-yle. Second position, it is get substituted to the CH2 group. Hence, 2-yle methyl. So, this is a methyl group is here. Okay, na? So, this is a phentolamine drug structure. So, these drugs can be used in the treatment of hypertension. Okay, this drug can be used in the treatment of hypertension. Next, used for the treatment of hypertensive crisis in clonidine withdrawal and cheese reaction. Okay. Okay. Next, next one is 𝘂𝙂𝙎𝙾 structure. Okay, next drug is 𝘂𝙂𝙎𝙾. See here in the 𝘂𝙂𝙎𝙾, first what is there? Phenoxy group is there. Okay, phenyl oxy group is there, along with benzyl group is there. Along with benzyl group is there. Next one is amine group is there. Okay. Next is amine group is there. So this is the drug structure. See, when it comes to the IUPAC name, first we need to identify the functional groups. What are the functional groups are there? Ether, amine group, correct? Ether and amine. See, among ether and amine group, which functional group will get first priority? That is, amine group will get the first priority. So how we need to write the IUPAC name? See, amine group, here it is containing 3 carbon, here 2 carbon, here 1 carbon is there. So longest carbon chain we need to select. Okay, hence the numbering is like this. Okay, this is the numbering. After that, 2 carbon containing we need to give the numbering. Next, 1 carbon containing, or else it is a benzyl carbon. Okay, now IUPAC name is 2-amine. Second position, what is there? Second position, it is containing amine. Hence we need to write 2-amine. Propane, 3 carbon containing, the it is contain 3 carbons, hence propane. Next, what is there? Phenoxy group. See, first carbon that is containing phenoxy group. Okay, next, what is there? Nitrogen that is containing 2 substitutions. What are those 2 substitution? One is N-benzoyl. See, N-benzoyl nothing but any substituent that is present on nitrogen, oxygen or sulfur, we need to write those particular atom. See, on nitrogen what is there? Benzyl is there. Okay, on the nitrogen only what is there? Chloro, 2-chloro. Second position chlorine is there, hence 2-chloroethyl. Okay, na? So this is the 𝘂𝙂𝙎𝙾 structure. See, used to prevent the hypertensive episodes during the operative manipulation of tumor in case of pheochromocytoma. Okay, nothing but prostate cancer condition, we can use this drug. Next, prazosin drug is there. Okay, when the prazosin drug is there, PR, letter PR indicates piperazine. PR indicates piperazine. Azosin is there. Okay, azosin nothing but that is derived from phenazolene basic moiety, ketone. Automatically we need to give the more priority to the ketone. So 1 carbon containing it is. Instead of here heterocyclic, it is a furan, then the drug is prazosin. If it is a tetrahydrofuran, then the drug is terazosin. Okay, doxazosin nothing but benzene. Okay, this is a benzene, it is a dioxane. Okay, benzodiazine nucleus is there, then we can call it a doxazosin structure. Now, first is ketone group is there, hence we need to give the number 1 position. Next, what is there? Heterocycle is there. This heterocycle we need to give the numbering. The numbering is like this: 4. Second position it is get substituted. Next, piperazine we need to give the numbering like this. Next, phenazolin numbering we need to give like this. Okay na? So that we can write the IUPAC name here, methanone. Methanone means one carbon containing ketone, hence methanone. Next, what is there? This heterocycle is there. What is the name of that heterocycle? That is furon. Hence we can write as a 2-furyl. Second position it is substituted. Next, piperazine. So it is containing attached to the piperazine. Piperazine, that is can be attached to the quinazolinal. Okay, quinazolinal. So this is a quinazolinal. See this quinazolin, that is containing substitutions. Okay, quinazolin, it is containing substitution. What is that? Amine group, amine substituent along with dimethoxy. Dimethoxy group is there. So fourth position it is containing amino group. Okay, 6,7 position it is containing dimethoxy, 2-quinazolinal. Okay, 2-quinazolinal. So this is a prazosin drug. Okay, name, structure, IUPAC name, along with terazosin, along with doxazosin. Okay, this drug can be useful for the treatment of scorpion sting. Okay, scorpion sting, in this condition we can use the drug. Next comes to the beta blocker drugs. Okay, beta blockers, that is a non-selective, that will act on both beta 1 and beta 2 receptor. Example is stop NP. S nothing but sotalol, T nothing but timolol, O nothing but oxyprenolol, P nothing but propranolol, nadolol, pindolol. That is stop NP. Okay, next one is selective drug, that is beta 1 selective drug. Okay, next one is beta 1 selective drug. Example is BBChem. B nothing but bisoprolol, betoxolol, celiprolol, atenolol, acebutolol and metoprolol. Okay, along with esmolol. Very important. See, beta 1 blocker, selective beta 1 blocker, also we can call it a cardioselective. Cardioselective beta blocker. Okay, also we can call it a cardioselective beta blocker. Next, selective beta 2 receptor. Okay, example is butoxime. Example of the drug is butoxime here. Next, beta blocker, that is mixed acting, that is that can act on both alpha and beta receptor. Example is labetalol and 𝘾𝙀𝙬. The example of the drug is labetalol and 𝘾𝙀𝙬. See, 𝘾𝙀𝙬 and labetalol are the agents. Both can be acts as an antagonist at alpha and beta receptor. Okay na? Both the drugs can be used as a antihypertensive drug. Both the drugs can be used as a antihypertensive. But 𝘾𝙀𝙬, that is having okay, that has been used to treat the cardiac failure, congestive cardiac failure or congestive heart failure. In this condition we can use the drug 𝘾𝙀𝙬. Along with that okay, along with that, see, propranolol drug is there. See, propranolol is a drug that can be used in the treatment of anxiety and migraine. Next, timolol and betoxolol drugs are there. These two drugs can be used in the treatment of glaucoma. Next, what are the important points to be focused from this topic is basic ring of timolol, atenolol, pindolol and propranolol. Next, classification of drugs, synthesis of important drugs, atenolol, timolol, propranolol and oxyprenolol, along with what is the side chain that can be identified in the different drugs. Okay, next, beta blockers that can be used in the treatment of tachycardia because of decreased heart rate. So it is having negative chronotropic effect, that is we can call it a decreased heart rate. Decreased heart rate, hence the drugs can be used in the treatment of tachyarrhythmia. Next, along with this, the drug can be used in the angina pectoris because these drugs decreases the workload on the heart. Along with that, because of decreasing the cardiac output and inhibit the release of renin, the drugs can be used in the treatment of hypertension. Okay, these drugs also used in the tachycardia because of decreased AV conduction. because of decreased AV conduction. But these drugs, okay, beta blockers we cannot use in the art black condition. Next, first generation beta blockers, also we can call it a non-selective beta blockers. See, non-selective beta blockers, this is having the side effects like bronchoconstriction in asthmatic patient, fatigue and tiredness of limbs due to decreased cardiac output. Next, CNS effects like dizziness, nightmares and sedation because due to the presence of lipophilic, means lipid soluble beta blocker, that is propranolol, pindolol and oxypranolol, along with coldness of extremities also can be caused by these drugs. Okay, selective beta 1 blocker drugs, just now we have discussed this. Next, practolol, it is a first cardio selective drug they have developed. So this is the structure of practolol. This is withdrawn from the market because of side effects like skin rashes and peritonitis. Next, propranolol drug is there. Next one is propranolol. See, pro nothing but propyl group is there, isopropyl group. PR nothing but another propyl group is there. AN, that is alpha naphthol. AN nothing but alpha naphthol. OL nothing but alcohol. What is that? Alcohol. So this letter and this letter again they have taken. So they have taken OL from the alcohol name. Getting a now, so this is the structure. Okay, this is the structure is there. In this structure, can you people identify what are the functional groups? Okay, hydroxy group is there. Okay, hydroxy group along with amine group is there, along with ether group is there. Ether, hydroxy and amine. See, among these three groups, ether group will get the first priority. Okay, ether group will get the first priority. So how we can write the IUPAC name? First important highest priority functional group is alcohol. So start the numbering from here. So 1, 2 and 3 position. Okay na? Then what is there here? First position, what it contains? 1 and 2. So 1-methyl ethyl amino, 1-methyl ethyl amino, that is located at first position. Next, third position. Okay, what it contains? Third position, it is containing naphthalene. So this is a naphthalene along with oxy, hence we can call it a naphthoxy. Propane 2-ol. See, propane nothing but 3 carbon containing. At second position, what is there? Alcohol is there, hence propane 2-ol. So this is a propranolol drug. Next, timolol drug is there. See, timolol, that is containing sulfur containing drug. Okay, more nothing but morpholine structure is there. Okay, next, OL nothing but it's contain alcohol. Okay, it's containing the alcohol group. See here, same alcohol ether group is there, amine group is there. So the numbering we need to starts with alcohol containing group. Alcohol containing carbon we need to give the first priority, then heterocyclic ring like this, then morpholine ring numbering like this we need to give. After giving the numbering, first we need to write propranolol. See, alcohol is present at second position, hence we can write propranolol. See, that is attached to the oxy, hence oxy group is there. Okay, one position, what is there? Thia. Okay, thia group is there, nothing but sulfur group. Diazo, nothing but 2 nitrogen group is there. So second and fifth position, what is there? Diazo. Ol nothing but 5-membered ring it is. Okay, 3-ol nothing but third position it is get substituted. Okay, next, what is there at fourth position? See, at fourth position, what is there? Morpholine. So this is the structure of morpholine. Morpholine structure is there, that is at so it is containing the morpholine structure. Next, tertiary butyl. So what is there? This is a tertiary butyl group is there. Tertiary butyl amino, that is at first position. So this is the third, nothing but this one. First position, nothing but tertiary butyl amino group is there. Next, pindolol drug is there. Okay, next drug is pindolol. Pindolol drug, okay, when comes to the pindolol drug, here what is there? P nothing but propyl group is there. Next, indolemite is there. So basic nucleus is indole here. OL nothing but alcohol group is there. So this is the pindolol. See, same alcohol, ether and amine group. So we need to select the alcohol. So start the numbering from alcohol group containing carbon 1, 2, 3. So propane 2-ol is the basic nucleus is common. Okay, propane 2-ol is there. Third position what is there? Okay, isopropyl. This group we can call as a isopropyl. Isopropyl amino. Hence isopropyl amino is there. 1H indole oxy. So this is the indole along with oxy. Hence we can call as a indole oxy group is there. See, this is a pindolol drug structure. See, indole numbering is this one. Like this we can give the number. So here this carbon we cannot give the numbering because quaternary carbons are there. Quaternary carbons very less reactive. So we cannot give the numbering. See, how we can develop the selective beta blockers. See, selective beta blockers, how we can develop nothing but one aromatic ring is there. On that aromatic ring, we need to add the polar groups like OH, okay, NH2, okay. Next, amide group. Polar groups we need to add. See, polar group, this will forms hydrogen bond. Okay, this will form hydrogen bond. Okay, polar functional group, it will forms the hydrogen bond. Getting a? See, polar group, it will form hydrogen bond with receptors. Like this it will forms. Like this, the polar functional group that will that can forms the hydrogen bond. See, because of formation of hydrogen bond, these drugs are selectively bound to the beta 1 receptor. The drugs that will selectively bound to the beta 1 receptor. Hence, see, atenolol. See, atenolol, that is containing amide group. Amide group, it is a polar, it will form hydrogen bond with only beta 1 receptor. Hence we can call it a selective beta 1 receptor. Okay, so this is the IUPAC name. See, first what is there? Same alcohol group, ether, amine group. See, among these three group, which one we need to give more priority? That is alcohol group we need to give the more priority. Okay, so numbering we need to start with, sorry, see, alcohol is there, ether is there, amine is there, amide also there, amide group also there. We need to remember that amide group. I have forgot. See, amide group is there. See, when amide group is there, first we need to give more priority to the amide group. Amide group containing carbon 1, next carbon is 2. Hence, after that benzene, we need to give the numbering like this. Okay, next 3 carbon containing propyl group. Propyl group like this. After that, we need to write the IUPAC name. Acetamide. See, 2 carbon containing amide is acetamide, that can be attached to the phenyl. Phenyl group that can be attached to the propoxy. See, propoxy nothing but 3 carbon containing oxy, hence propoxy group. Next, what is there? Third position, second position, it is containing a hydroxy group. Third position, it is containing what it contains? Propane 2-ol amino. Okay, propane 2-ol nothing but we can give numbering 1, 2, 3. Okay na, 1, 2, 3. Second position, it is get substituted, hence propyl 2-ol. Second position, it is attached to the nitrogen, hence 2-ol. That is propane 2-ol amino. Second position, it is having hydroxy group. Getting a? See, this 4 indicates the position of this one. This 2 indicates this one. Getting a? Next, atenolol. So next one is esmolol drug. See esmolol nothing but that containing ester. See ester containing drug, so it is ultra short acting drug due to the presence of ester bond. Hence these drugs can be used in the hence these drugs can be used in the treatment of emergency arrhythmia. Okay, used in the treatment of emergency arrhythmia condition. See here, what is their functional group we need to identify: ester, alcohol, ether and amine. So this 3-4 functional group is there, so ester group will get first priority. So ester group containing carbon we need to give the first priority, that is 1, 2 and 3. Okay, next benzene we need to give the numbering. Next 3 carbon containing, see propanoate, 3 carbon containing ester, hence we need to write propanoate. That can be attached to the phenyl group. Next propoxy group is there, 3 carbon containing propoxy group. Okay, second position it is containing hydroxy group. Third position it is containing propyl 1, 2, 3, propyl 2-iyl amino group. Okay na, propyl 2-iyl amino. See anything that is present on the oxygen atom in the ester group, if anything present on the oxygen atom, we need to write as a, always we need to write as a prefix. Getting a? Next metoprolol drug. So metoprolol drug, it is containing methoxy group. See methoxy group is there, propranolol drug is there, prolol nothing but propyl group containing alcohol. Along with that it is containing methoxy group. See ether group is there. See ether group is there, alcohol and amine group is there, along with ether group is there. Say among this ether, alcohol and amine, alcohol group will get first priority, so we need to start the numbering from alcohol containing group. So numbering is 1, 2, 3 like this. After that benzene we need to give numbering like this. Getting a? So IUPAC name is, first we need to write the propane to all. So propane to all is there. Okay, third position what is there? Propane 2-iyl amino, 1, 2, 3, 3 carbon containing. Okay, hence propyl 2-iyl amino. One position what it contains? One position what it contains? One position, that is 4-methoxy. See, sorry, not 4, 2-methoxy. See second position it is containing methoxy. Okay, ethyl group, 2 carbon containing ethyl. Next benzene with oxy, that is phenoxy group. Phenoxy group is there. Getting a? So this is a metoprolol drug structure. Next betoxolol drug is there. See betoxolol nothing but beta. See beta position is there. See this is the functional group. Amine is the functional group here. Alpha carbon, beta carbon. To this beta something is there. What is that something? Methoxy group is there. To that beta methoxy group is there. Hence betoxolol alcohol group is there. Along with alcohol group is there, hence betoxolol is a name for this one. What is their functional group? Ether, amino, alcohol, ether. So automatically alcohol group will get the first priority, that is propane to all. Okay, propane to all. See numbering is like this, 1, 2, 3. Okay, benzene 1, 2, 3, 4, 5, 6, 1 and 2. Okay, now what is their first? See cyclopropyl. So this is a cyclopropyl. Methoxy group is here. Next ethyl group is here. Okay, next one is ethyl group is here. Next phenoxy group is there. Amino, see amine group should be there. Ethyl amino, phenoxy. Okay, phenoxy, this is a phenoxy group is there. Along with third position what it contains? Third position what it contains? Isopropyl amino. Okay na, isopropyl, this functional group also we can call it isopropyl, hence isopropyl amino also we can call it. Okay, next bisoprolol drug. Okay, bisoprolol drug, that is containing 2 isopropyl group. Bisoprolol is a drug that is containing two isopropyl group, hence we can call it a bisoprolol drug. OL nothing but propranolol. Okay, two isopropyl group containing drug, that is bisoprolol. Same ether, alcohol, amine, ether and ether. So automatically alcohol group will get the first priority. So we need to write the alcohol group first. That is 2-propranolol. That can be attached to the amino. See isopropyl amino. See this is isopropyl amino. This is at number 3 position. So number 3 position it contains isopropyl amino. Next, what is there at first position? Okay, at first position what it contains? See isopropoxy, oxygen is there, isopropoxy, ethoxy, two carbon containing oxygen, ethoxy, along with methyl group. Next one is phenoxy group. So this is the phenoxy group is there. Numbering is like this, it is. Phenoxy group is here. Then isopropyl amino 2-propranolol. Getting a? So this is the bisoprolol drug. Many times they have asked in the Gpat. Next, labetalol drug. See labetalol. See labetalol drug that is containing LA, nothing but also we can call it a YL. That is phenyl group is there. B nothing but what is there? Butyl group is there. ET nothing but ethyl group is there. A nothing but amino group is there. Alcohol group is there. So this is a labetalol structure. Okay. Next, these drugs can be used in the treatment of hypertensive episodes in pheochromocytoma. See functional group, what is there? Amide group is there, alcohol amine group is there along with alcohol group. So amide group will get the first priority. So start the numbering from the amide group containing carbon like this. Next 1 2 1 2 3 4 like that. Then we can write the IUPAC name. What is there? Benzamide is there. Getting a benzamide, benzene that is containing amide, that is benzamide, basic nucleus attached to the ethyl group. Okay, ethyl group is there, amino group is here. Ethyl group that is containing hydroxy, so 1 hydroxy. Next, what is this? Entire substitution is there. What is the name of the substitution? That is 4-phenyl butone. Fourth position it is containing phenyl, hence 4-phenyl butone 2-yle. Second position it is substituted, that is amino. Along with that, what is their second position it is having? Second position it is having hydroxy group. Getting a? So that is the labetalol. Next, structural activity relationship of aryl propanol amine, that is beta blockers. So this is a basic nucleus. It contains aromatic. See, aromatic ring is aromatic ring is possible and heteroaromatic rings also introduced. Example in case of pindolol and timolol. Ether group is there. See, ether group that is involved in the formation of hydrogen bond with receptor. That is involving in the formation of hydrogen bond with the receptor. If people are replacing with sulfur with oxygen with sulfur or ethyl group or N-methyl group is detrimental, mean the activity might be get reduced. See, any substitutions on these two position. Okay, any substitutions on these two position. Okay, what will happen? Methyl group increases the metabolic activity but lowers the increases the metabolic stability. Stability of the drug is stable towards the metabolism, but it will decreases the activity towards the alpha and beta receptor. Amine group is there essential. It leads to the formation of ionic bonding with receptor. It must be secondary amine. Okay, it must be secondary amine. Next, what is there? branched alkyl group is there. Okay, branched alkyl group is there, that is n alkyl group substituents such as isopropyl and tertiary butyl. These two groups are essential for the beta antagonistic activity, because what is it means the receptor that contains, the receptor that is containing hydrophobic pocket, because the receptor that contains hydrophobic pocket, hence this carbon, that is isopropyl group and butyl group, that will go and bind to the hydrophobic pocket of receptor. Next, alcohol group is there. See, alcohol group, this also will form ionic bond with the receptor, so it will also form ionic bond with receptor. Okay, so with this we have completed the topic of alpha and beta blocker, that is sympatholytics topic is over. Yesterday we have discussed cholinergic agonist, today sympatholytics. Okay, tomorrow we can discuss sympathomimetics, next class we can discuss parasympatholytics. Okay, any doubts? If you people have any doubts regarding the class, is there any doubts? Okay, no doubts. Okay, now I will close the session.